For example 2C, we got to go through here and we have to find out your zeros, your vertical asymptotes, and your horizontal asymptotes. So let's find your zeros by setting the numerator equal to 0. So when you do that, you subtract 9, divide by 2, x equals a 9 halves, or for those of you that are afraid of fractions, that's the same thing as negative 4.5. So we're going to go back 4.5 and put a little dot right here. Next, you need to find your vertical asymptote. So you find your vertical asymptote, and in this case, you're going to set 2x squared minus x minus 3 equals 0. So here's your denominator. And when you factor this, you end up getting 2x minus 3 times x plus 1. I'll spare you the steps for all the steps of factoring. I figure you can get that on your own. And then when you solve each of these equations, you get a 3 halves and a negative 1. So we're going to put in our vertical asymptotes. There's negative 1. Here's a positive 3 half. And now we need to find your horizontal asymptote. So our HA. And if you look at your degree on top, which is a 1, and your degree on the bottom, which is a 2, then your numerator is less than your denominator, which gives us y equals 0. So you put your horizontal asymptote in here, and notice that you have this little weird 0 and an asymptote. So once again, another little funky graph. So now we make our table of values. And you should really include at least 2 to 3 points on each side of your asymptote. So if you have an asymptote at negative 1, let's go negative 3 and negative 2. If you plug a negative 1 in, that's going to be undefined. So let's go 0, 1, and 3 halves would be undefined. So let's go 2, 3, and we'll put a 4 in here. So now when you plug all these into your equation, if you want to find f of negative 3, remember that's going to be 2 times negative 3 plus 9 all over 2 times negative 3 squared plus a, whoops, sorry, that's supposed to be a minus. Minus another negative 3 minus 3, you end up getting the value of a 0.17 or 0.2. So, and then what you're going to do is you're just going to plug all those in for the rest of your values, and you get a 0.7 here for negative 2. When you plug a 0 in, you get a negative 3. You get negative 5.5. Then you have 3 halves, you wouldn't have anything. So then for 2, you get a 4.3. For 3, you get a 1.3. So you plug a 4 in there, you get a 0.68 or 0.7. So then you go through and you plot all of these points. So you get all your points graphed, and you're going to notice that on the right, this graph goes down to the right. Oh, doesn't touch your asymptote. In the middle, we got an issue because this goes down like so, but we don't know if it will either turn around and go back up or go down, or if it's going to go up like that. So we need to plug in one more point. We need to plug in a 1/2, and if you plug in a 1/2, you're going to find out you get a negative 4. So oops, sorry, negative half. So you plug a negative half and you go down 4, which would be here. So that means this point is going to go back down. So you do need to make sure that this goes either up or down. So then these points extend up, and you get this funky little point here that is actually going to be on your asymptote, and then that's going to stay on the bottom. So that is how you're going to do 2C.